Hey everybody, Trey here. Welcome back to another video. Now that we've had a day or so to decompress from our moderate risk tornado outbreak back on Saturday, December 28th, I thought it would be good to do a meteorological breakdown on that event. Very interesting setup, very interesting convective evolution within that setup that has led to, as of the time of this recording on Monday morning, December 30th, 52 tornado reports in total from Texas all the way into Alabama and Georgia. Most of those concentrated in a couple of areas, the first being southwest into central Mississippi. You see a number of tornado reports there, mostly due to a tornadic supercell that produced a pretty stout tornado near the towns of Bude and McCall Creek, Mississippi. Very stout tornado you see in this drone footage there. Produced some pretty significant damage as well as some injuries. Here's a little bit of a closer in view of this tornado as it crossed Highway 54 near the town of Bude. Very large, intense tornado there. The other area was down in southeast Texas. You see a bunch of tornado reports there. This was somewhat unexpected, not quite in the main moderate risk area, but we had a number of supercells produce some tornadoes down there, including a couple of EF3s, one near the Houston metro area, and one that produced a very long track tornado, an EF3 that tracked from south of Houston all the way to near the Port Arthur, Texas area along the Louisiana-Texas border. That is a full track of almost 100 miles continuously in progress there. So a very impressive tornado. Here's a shot of that tornado from a barge near Port Arthur. This was rain wrapped for most of its life, but you can see that dark lowering there appears to be the tornado, which again was rated EF3 with max winds in excess of 160 miles an hour preliminarily. This setup perhaps did not quite reach its ceiling, even though there were a number of tornado reports, again, over 50 tornado reports at this point, with several significant tornadoes. You'll notice over Louisiana quite a lack of tornado reports. That was right in the center of the moderate risk. So I thought it would be good to do a little bit of a breakdown on this event, including a few of the reasons why this setup may not quite have reached its ceiling, and also focus on the southeast Texas area where that long track tornadic supercell occurred. Take a look at some of the reasons why that area may have been slightly more favorable for long track tornadic supercells than elsewhere within the setup, even though it was outside of the moderate risk. So without further ado, let's go ahead and get started. Just as a reminder of what the outlook from the SPC looked like on Saturday, this was the midday day one outlook. They had a moderate risk level 4 out of 5 there in the red shaded region, so far east Texas into much of central and northern Louisiana, central into south central Mississippi, into western Alabama, with a large enhanced risk surrounding that back into east Texas, down along the Gulf Coast there and into central Alabama, with a large slight risk as well, extending all the way back into the kind of the I-35 corridor there in east central Texas, and then over into western Georgia and down along the Gulf Coast. You'll notice the southeast Texas area, a lot of the track of that supercell occurred in the marginal and slight risks there, not even close to the enhanced or the moderate risks. So it was a little bit of a surprise that such significant tornadic activity occurred that far southwest. We'll take a look at some reasons why that area may have been a little bit more favorable in hindsight for significant tornadic activity than some of the areas farther east, but we'll get to that here in just a second. But overall, there was a moderate risk level 4 out of 5 in the red shaded region there, with a 15% hatched area for tornadoes. Significant tornadoes were a distinct possibility, especially in the red and yellow stippled regions there, the 15 and 10% hatched tornado areas, along with a significant damaging wind threat through north central Louisiana into Mississippi. And large hail was expected to be a little bit of an issue. Did not end up being so much of a threat. It was mostly a damaging wind and tornado threat with this setup, but it was a potent setup for all hazards nonetheless. All right, let's take a look at the meteorology behind this setup. We'll start out at 500 millibars at 12Z, 6 a.m. Central Standard Time on Saturday. And right away, you see our main player with this setup. It was this compact but still quite potent trough moving across the southern U.S. Its axis to start the day here at 12Z, situated somewhere from the Texas Panhandle down into central Mexico. The jet streak, the main jet streak with this trough, was relegated to the backside of the trough axis there, 70 to 80 knots of flow in a fairly compact jet streak on the backside of the trough, which indicates that the trough was still in its maturing phase. Usually when you see the flow rounding the base of the trough and going into the exit region of the trough, it is starting to reach peak intensity, but here, most of the strong flow still on the backside of the trough, so this trough was definitely still in its maturing phase. Slightly positive tilt to start the day was expected to take on a little bit of a negative tilt with time Out ahead of the trough axis, we were in this broad belt of southwesterly flow here from the eastern half of Texas all the way eastward into Arkansas, Louisiana, Mississippi to start the day. And that didn't really change during the daytime hours especially. I'll fast forward here through the setup, and you see that the trough starts to take on a little bit more of a neutral tilt. This is at 18Z, so about midday on Saturday. The trough fairly neutrally tilted here, the jet streak starting to round the base of the trough. And still out here across Louisiana and Mississippi especially, we're kind of in no man's land, as I like to call it. We're not really close to the exit region of the trough, and we're not really far out to the east, starting to close in on the ridging out to the east of the main trough. But we're just kind of stuck in the middle in this broad southwesterly flow, not a ton of forcing within that area well ahead of the exit region of the trough. So that was a bit of a concern to start the day, was how much forcing we'd have to sustain warm sector supercells. And that did appear to come into play with this setup. We'll get into that more in just a bit. But overall, throughout the day, we still had broad southwesterly flow across the region, so deep layer shear was certainly favorable for supercells. And as we went through the day, the trough continued to dig down into the south. We started to see it take on a little bit more of a negative tilt with time. This is at 22Z. And by this time, the forcing had started to overspread the warm sector. So we saw an increase in convective coverage and intensity, but mostly in the form of a QLCS. All of that activity in Texas and some of that had formed out ahead on confluence bands out in western Louisiana had started to conglomerate into a fairly pervasive QLCS here that moved across the region. And that would become our main severe weather maker going into the evening hours as the forcing increased. And we didn't really see a ton of warm sector supercell development continue through that time frame. Interestingly enough, it was mostly the QLCS, but in the time frame during the afternoon, we still were in a little bit of that stuck in the middle with not really much forcing over the warm sector to initiate and sustain a lot of warm sector supercells. Up at 300 millibars, we see much of the same. Our trough back here in West Texas to start the day, the axis somewhere in here. And as we started to go through the morning and early afternoon, defluence in the exit region of the trough started to increase. You see all these pink contours here. That is the SPC's way of denoting defluence on the 300 millibar chart. All these pink contours here, I'll change colors real quick to make it a little bit easier to see my annotations, but right in there, that's where all that defluence was taking place. You see a little bit of change in the wind vectors here across southern Oklahoma, winds more out of the due south into North Texas as well, and then down along the Gulf Coast, much more southwesterly flow, leading to some nice defluence aloft across that region. Starting to impinge upon northern Louisiana as well. Still out in here across Louisiana and Mississippi, across much of the warm sector, that central and eastern portion of the moderate risk, we were not seeing much defluence at all. You don't see a ton of change in the wind vectors across northern Louisiana out of the south-southwest. It's pretty much the same out here across southern Louisiana and southern Mississippi. So not a ton of defluence aloft, adding to the mounting evidence that we just did not have a ton of forcing over the warm sector in this regime. Eventually we would, as the trough swung through, took on a little bit more negative tilt with time. Going into early evening, that defluence started to overspread the region in Arkansas, Louisiana, and Mississippi to support increasing convective intensity and coverage, but again, mostly in the form of the QLCS rather than discrete supercells. Storms developed early in the day on Saturday, and that was due to a little bit of a shortwave that developed across Texas, Louisiana, and Mississippi, well out ahead of the main shortwave axis. Once again, our main shortwave was situated back here across West Texas into Mexico, and if you keep your eyes on the region from Texas into Louisiana and Mississippi, you'll see a little bit of a shortwave developing out ahead of that main trough axis. Here we are at 15Z, 9 a.m. Central Standard Time, and you see a clear little kink in the height contours here across from the Arklatex southeastward into Louisiana and Mississippi. Clear evidence of a little shortwave that had developed within the flow out ahead of the main shortwave axis. This was a bit of a complicating factor because, as you see, it initiated quite a bit of convection out ahead of it. Lots of convection here from Mississippi into Arkansas and into the Arklatex out ahead of the shortwave. But behind that shortwave was a little bit of subsidence or sinking motion, which is typical with all shortwaves. Rising motion favored out ahead of the shortwave, subsidence or sinking motion favored on the backside of the shortwave. We talked about in our forecast discussion leading up to the event that the degree of morning convection would play a role in how significant the afternoon activity would be. That activity moved off into Mississippi a little bit, but behind this area into far east Texas and Louisiana, we were dealing with quite a bit of subsidence. So we were still, again, in no man's land out here, well ahead of the main shortwave, so a little bit removed from the main forcing with that shortwave. but in this area of subsidence behind the shortwave that was moving out to the northeast. So we were a little bit caught in the middle, and that was going to be a complicating factor for this portion of the setup. At the surface to start the day, we had a little bit of a surface low situated in northwest Texas with broad southerly and south-southeasterly flow in its warm sector to the south and southeast. Throughout the day, the low would move off to the east and deepen a little bit. It's a little bit tough to tell exactly where the center is as we go into the afternoon. It was mostly a broad surface low, as you see here across Texas into the Arklatex region, with maybe a center that started to reshape there in northern Louisiana, just out ahead of the convection back here to the west. But overall, we would see some deepening of the surface low with time, although not a ton. It wasn't a really super tight surface low as we see in a lot of significant tornado events down here in the southeast and in the plains for that matter. And that was because the trough didn't really change a whole lot in the mid and upper levels with time. We started the day in that kind of intensifying phase with most of the stronger flow relegated to the backside of the trough. I'll pull up the 500 millibar map here so we can see that. Again, so to start the day, that stronger flow relegated to the backside of the trough, slight positive tilt nature to the trough. We didn't change that a whole lot going through the day. A lot of that flow still was relegated to the backside of the trough by early afternoon, starting to round the base of the trough, and the trough overall was taking on a little bit more of a neutral to slightly negative tilt. So we were seeing a little bit of deepening with the mid and upper level trough, a little bit of deepening with the surface low as well, but it wasn't a really strong intensification of the surface low because we weren't seeing a super strong transformation in the geometry and intensity of the trough as we went into the afternoon. At 850 millibars, a broad low-level jet was in place to start the day, mostly on the more modest side for significant tornado events in the southern plains and southeast. Mostly just 30 to 35 knots of flow here across Texas, weaker off to the east, but that would increase somewhat throughout the day, and we would see a broad area of 30 to 40, 45 knots or so of flow by early afternoon. This is at 19Z. So 1 p.m. Central Standard Time, you see 40 knots or so of flow across a broad area from southeast Texas eastward into now making its way into the Mississippi River Delta region, and with time, that low-level jet would spread east, 40 to 45 knots of flow or so across Louisiana into Mississippi, so out of the south, mind you, as well. So with that strengthening low-level flow with time, not on the higher end, certainly, for significant tornado events that we've seen in the past, nothing like a 60 or 70 knot low-level jet that would really ramp up the low-level shear, but still, 40 to 45 knots of flow out of the south or south-southwest across this area, more than adequate for enlarging those photographs, pumping that moisture in continuously to the region, and allowing for strong low-level shear for a significant tornado threat, and strong deep layer shear, especially with more southwesterly 500 millibar flow. Taking a look at our raw surface data at 12Z, we can see a nice counterclockwise circulation around the center of the surface low, putting it somewhere here in northwest Texas to start the day. Down to the south of that, we have a couple of boundaries. What appears to be a frontal zone, somewhere in this vicinity, it looks like here. This may be our Pacific front, not a full-blown cold front, not a very strong temperature gradient across these two fronts. Temperatures in the 50s and low 60s on the west side of the front, temperatures in the upper 50s and low 60s on the east side of the front. So not a very strong temperature gradient nor moisture gradient between both sides of the boundary. That usually indicates more of a Pacific front, not quite as strong of a gradient across the boundary, rather than a cold front, which we'd see a lot stronger of a temperature gradient and moisture gradient across the boundary. A dry line was also situated to the south as well, probably somewhere in this vicinity here. Moisture was still advancing at this point, so we had a broad warm sector in place with drier air to the west, but the warm sector still advancing. Looks like it would be somewhere in this vicinity here. We see 60s dew points out across the southern and southeast Texas area, 50s and 40s to the south as well. So the dry line was certainly setting up back in here. A little bit of a disjointed surface pattern. That was one of the things we talked about as potentially being a downfall of this setup. Anecdotally, when you have such somewhat of an ill-defined surface pattern and your features are not super well defined, that tends to lead to more of a disorganized severe threat across the warm sector. Not so much as disorganized storms, non-supercellular or non-severe storms, but overall a more widespread convection, not really focused in any particular region. And we saw that in this event. We had a lot of different confluence bands out in the open warm sector, a lot of messy convection near the synoptic warm frontal zone, which looks to be somewhere in this vicinity here. You see the easterly winds on the north side of that boundary here in Oklahoma, far north Texas, and then more southeasterly winds to the south. So our synoptic warm front somewhere in there. A lot of convection along and to the north of that throughout the morning hours, but not a super focused surface pattern here. Something that we can, not something that we typically associate with significant tornado events across the plains and into the southeast. You'd like to see more of a well-defined surface setup, but still plenty of robust warm sector to support a significant severe threat. Lots of robust moisture here, dew points in the 60s and even 70s here along the Texas coast to start the day. And off farther to the east, we'll take a look at our southeast sector. That warm sector extended well off to the east as well, with 60s and 70s dew points extending all the way into far southern Mississippi and Alabama here at 12Z on Saturday. So we had our synoptic warm front somewhere in this vicinity here, a lot of convection along that as well. And then to the south, we had maybe somewhat of a marine front separating our most robust moisture down to the south with slightly more meager moisture to the north. Maybe somewhere in here we have just a subtle moisture gradient in there, dew points in the upper 50s and low 60s to the north, dew points in the mid to upper 60s and 70s to the south of that boundary. So this is a common setup at the surface in these southeast events. You'll have your synoptic scale warm front connected to the actual surface low, but to the south you'll see another more modest, more subtle moisture gradient that acts as somewhat of an effective warm front as well, and we call that more of a marine front. So it's just the leading edge of the best, most robust moisture in our event. So that looks to have set up somewhere in there, lifting to the north with time. Our synoptic warm front somewhere in there as well, and the surface low would move off to the east during the day. I'll go back here to our Texas sector. Warm surface low would move off to the east during the day. We would set up a very broad warm sector, that broad warm sector extending all the way into the Mississippi-Alabama region here, leading to that long-duration severe threat. Anytime you have such a broad warm sector, it's a lot of real estate for severe storms to take advantage of, extending all the way basically from central Texas eastward to the southern Mississippi-Alabama area. That is a lot of real estate for storms to take advantage of. A lot of area in which the parameter space is favorable for severe weather, and that's why we saw a very long duration severe threat with these storms initiating in central Texas, moving all the way across this warm sector as a severe complex. And then you have plenty of room, of course, for prefrontal warm sector, open warm sector supercells here on any confluence bands. We did see some evidence of confluence bands going forward here. I will fast forward it a little bit to maybe 17Z here. Very subtle confluence bands, so denoting where our dry line and Pacific front are, somewhere back in this vicinity here. There was your western extent of the warm sector. A couple of confluence bands we see in here potentially. Winds more out of the southwest, closer to that boundary. A little bit more backed flow out in here. So we definitely had a confluence band setting up near the Houston metroplex, and that was able to initiate those supercells near the Houston area and down to the south, where that significant long track tornadic supercell was able to initiate. It was on this confluence band well out ahead of the actual dry line and Pacific front out here in the open warm sector near that area. Off to the east, there were likely other confluence bands as well. It can be a little bit difficult to tell where exactly they'll set up on surface data, but if we go toward 1819Z here, that confluence band back to the west over southeast Texas, perhaps a little bit of one in here as well across eastern Louisiana into Mississippi. Much more backed flow across Mississippi as well, helping to strengthen low-level shear out there the most. A little bit more southerly flow out here in Louisiana, still favorable for all severe hazards and tornadic activity there, but a little bit more backed flow in Louisiana, a little bit more southerly flow to the west, so maybe a confluence band in there, and perhaps some other subtle confluence bands that we just can't make out on the surface obs here across these regions. Robust air mass would again make its way northward through the area. Temperatures in Mississippi, though, stayed on the cool side in the upper 60s. We'll talk about that later as well, but that warm sector would shift off to the east with time, and then we would see that threat shift off as the warm sector shifted into Alabama, Mississippi, Alabama, and Georgia, and even the Florida Panhandle, going into the evening and nighttime hours Saturday into Sunday morning. The environment was already favorable for tornadic supercells from the get-go. This is the 12Z observed sounding at Lake Charles in far southwest Louisiana, and this is a very favorable profile for all hazards of severe weather. Our instability, very strong to start with, over 2,200 joules per kilogram mixed layer CAPE. So even though it was only 6 a.m. Central Standard Time, the atmosphere was already quite unstable and uncapped. Not much convective inhibition remaining, if any at all here. -6 convective inhibition, that's essentially negligible. So we were already uncapped, already very unstable by this point, even though it was 6 a.m., with a wind profile favorable for tornadic supercells. Strong deep layer shear, lengthy hodographs, effective bulk shear in excess of 40 knots, with some low-level curvature as well. Winds veering and strengthening modestly with height, leading to effective storm relative helicity in excess of 180 meters squared per second squared, along with some of that hodograph curvature in the low level. So already our environment was favorable for tornadic supercells from the get-go. It's no wonder that we had a mini supercell mode from the get-go, as our storm relative inflow was quite small. If you recall from our videos in the past on the channel, storm relative inflow is basically you draw a vector from your storm motion to your level of interest, particularly when we're dealing with storm relative inflow in the low levels of the hodograph. So we'll use the surface here. You'll notice that that vector is quite small, generally about 20 knots, maybe just over 20 knots or so, which is on the low side. And storm relative inflow corresponds to how much mass a storm is ingesting. So a supercell that has stronger storm relative inflow is ingesting more mass, leads to a larger supercell. Smaller storm relative inflow means a storm is not ingesting as much mass, which leads to more mini supercell type storms. And that's exactly what we got. This is our radar picture from right about 8 a.m. Central Standard Time as those supercells were approaching Alexandria. See the hook echoes on those storms, nice little bean shape with those supercells there. These produced some tornado warnings, but they were definitely on the smaller side, and it's no wonder because of that small storm relative inflow. But overall, our environment was favorable for tornadic supercells from the get-go, given that we had an uncapped, highly unstable, and strongly sheared environment, both in the deep layer and in the low levels. Farther to the east, instability was not quite as strong. This is the 12Z observed sounding at Jackson, Mississippi. Not quite as strong instability, but still more than adequate, 1,000 joules per kilogram mixed layer CAPE that was expected to increase as we went into the afternoon. Wind profiles not yet super supportive of significant severe weather. Still, deep layer shear was strong and would strengthen as the trough made its way off to the east. Low level shear on the weaker side, not quite in the low level jet core, which was still well off to the west at this point, across more so East Texas into western Louisiana. Much of the same story at Slidell, basically New Orleans, Louisiana at 12Z. Much skinnier CAPE than we saw at Lake Charles, and not a wind profile all that favorable for significant severe weather. All right, let's first zoom into the southeast Texas supercell and discuss some of the factors that may have allowed this area to be a little bit more favorable for long-track significant tornadic supercells than areas farther east. Here's some of the radar imagery of that supercell, clearly originated along that confluence band we talked about. Near or just to the west of the Houston metro area, you see a number of updrafts along the same band here. Clear evidence of a confluence band forcing all of those updrafts to initiate. Then as we get some mergers to occur to the southwest of the Hillcrest area, we get a bona fide supercell out of this little band. You can see the classic shape there. Starts off as a small supercell. As we talked about the reasons why the supercell was at the mercy of very weak storm relative inflow. So originally not a lot going into this storm, but as we kept getting mergers into this storm, it continued to increase in size, and you see there that the intense tornado was in progress as it crossed the bay. Larger supercell now with a lot of storms on its southwest flank, very intense velocity couplet as it moves off to the northeast, just paralleling the Gulf Coast. And then as it goes south of Port Arthur, it continues to be strong, and then as it crosses into Louisiana, finally dissipates there to the southwest of Hackberry. The first reason why I think southeast Texas was a bit more favorable was that simply the forcing was stronger there. As we talked about before, the Louisiana Mississippi corridor was a little bit caught in no man's land, too far ahead of the exit region of the trough to really feel the influence of the forcing for ascent from the trough itself, and then behind that secondary shortwave that developed out ahead of the main trough that we looked at on the 700 millibar data. It was just within this broad southwesterly flow, not much forcing at all within that area, but farther southwest, here in southeast Texas near the Houston area, watch what happens with the trough. We'll go forward. The supercell starts to develop just after 15Z along that confluence band to the southwest of the Houston metro area. Right at that time, we're starting to see the stronger forcing from the trough right out ahead of the jet streak start to impinge upon that region, helping to increase forcing for ascent in that area and really help storms that fired along that confluence band sustain. We go forward into the early afternoon hours as that supercell was ongoing. You can clearly see the confluence band in the radar data underneath the 500 millibar map there, right at the leading edge of the jet streak. So much stronger forcing here. Again, Louisiana and Mississippi just well out ahead of that jet streak, well out ahead of the exit region of that trough, not really under the influence of strong forcing at all. So those storms that did develop in the open warm sector, for the most part, struggled to sustain and maintain significant intensity, save for the storm in southwest Mississippi, which we'll talk about here in just a bit. But farther back to the southwest in southeast Texas, we were right ahead of that jet streak, right ahead of the forcing associated with that jet streak in the exit region of the trough. So very easy for those storms to sustain themselves in that area compared to farther northeast in Louisiana and Mississippi. That jet streak continued to make its way off to the east with time, and then overall the overall forcing for ascent increased finally across southeast or across Mississippi and Louisiana. But by that time, most of the storm activity was in the form of a QLCS by early evening. The second reason southeast Texas may have been a little bit more favorable was thermodynamics. Let's take a look at a series of RAP model proximity soundings at Port Arthur, Texas, from 12Z up until the tornado's passage just south of town around 21Z. Starting off at 12Z, we see a very similar looking profile to what we saw with the 12Z observed sounding at Lake Charles. Very strong instability, over 2,300 joules per kilogram mixed layer CAPE, so plenty of instability, especially for this early in the morning. 70 over 70 at the surface, so a very moist low-level air mass. Plenty of instability coupled with adequate deep layer shear, lengthy hodographs, effective bulk shear in excess of 40 knots, with some low-level shear as well, some curvature there in the low levels of the hodograph, modest veering and strengthening of the winds with height, leading to just over 150 meters squared per second squared effective storm relative helicity. Very similar to what we saw at Lake Charles at 12Z. That environment does not change a whole lot going into the late morning and early afternoon, but we do destabilize quite a bit. Let's go to 18Z as the tornado was in progress back to the west and take a look at that instability profile. 3,100 joules per kilogram mixed layer CAPE, very, very thick, fat instability profile through the entire atmosphere. And the kicker here is the low-level instability. Take a look at that 0 to 3 kilometer CAPE value. Almost 180 joules per kilogram, meaning very, very robust low-level instability, very thick low-level CAPE profile there. And as we've talked ad nauseum on the channel before, the strong low-level instability can really aid in tornadogenesis in supercells. It helps to tilt and stretch any vorticity in the low levels, whether that comes from ambient vorticity from pre-existing boundaries or storm scale boundaries like the rear flank downdraft, any streamwise vorticity currents. It can help tilt and stretch that vorticity very, very efficiently into the vertical to aid in tornadogenesis in supercells. And just overall, stronger low-level instability is just better for tornadic activity. It can really help consummate that tornadogenesis process versus low-level instability that is on the weaker side. We also see very steep low-level lapse rates as well, in excess of 7.2 degrees Celsius, in excess of 7 degrees Celsius per kilometer. 7.2 degrees Celsius per kilometer is that 0 to 3 kilometer lapse rate. So very steep lapse rates in the low level, especially there in the lowest kilometer or so. That is very, very favorable for robust low-level updrafts, which are much more favorable for tornadic supercells. Shear profiles also adequate for tornadoes, perhaps not significant tornadoes maybe, with somewhat limited low-level storm relative helicity, only just above 150 meters squared per second squared. Certainly adequate for tornadic supercells, but maybe not screaming off the page as far as significant tornadic supercells. We'll come on to another reason here in just a second why that may have been, why we actually did get significant tornadic supercells here, despite somewhat limited low-level shear. Still, again, more than adequate for tornadic supercells, but not really so much for significant tornadic supercells, at least at first glance. That environment continues through the early to mid-afternoon as that tornado passed south of Port Arthur. Very favorable looking profile. We do see a little bit of an increase in low-level shear as we head toward 21Z, which is as the tornado is just south of Port Arthur. And look at that instability profile. Once again, very favorable look here. Very fat instability, strong low-level instability with really none of those little cape robbers, those little warm noses that can sometimes not quite cap the atmosphere entirely, but can maybe impede the robustness of low and mid-level updrafts. We don't see any of that. Very, very uniform lapse rate profile as we go up in the atmosphere. Very robust lapse rates, especially in the low levels, exceeding 7 degrees Celsius per kilometer. Let's compare that to a series of RAB model proximity soundings at Vicksburg, Mississippi. So right in that region it's right in the center of the moderate risk where a lot of the tornadic activity was expected to be. And again, just as a caveat, there was a significant tornadic supercell nearby, the Bude McCall Creek tornadic supercell, but we'll talk about that specifically in just a little bit. But overall, this gives us a good picture of what the overall environment looked like through parts of central and eastern Louisiana into western Mississippi. So to start the day, not quite as unstable as what we saw back out to the southwest in southeast Texas, but still plenty of instability, upwards of 1,000 joules per kilogram mixed layer cape there, 66 over 66 at the surface, and again, we were still removed from that low-level jet core. So very limited low-level shear at this point, despite strong deep layer shear. That low-level jet would increase with eastward extent as we went into the afternoon. As we went on with time, we see the impacts of the morning convection across this area. Some wonky profiles here, really sapping the instability here. This is at 17Z. Very, very skinny instability profiles. Contrast that with what we saw back out to the west in southeast Texas. We'll go to 18Z here just for a direct comparison. So this is 18Z at Vicksburg. Adequate instability, 1,300 joules per kilogram mixed layer cape, but very, very skinny instability profiles here. Let's go back to our 18Z sounding at Port Arthur. That is a much more thick cape profile, very, very thick cape profile. Of course, the value of instability much, much larger, upwards of 3,100 joules per kilogram mixed layer cape compared to only about 1,300, but a much thicker, fatter cape profile. That usually indicates much more robust, more efficient updrafts, stronger updrafts overall compared to a skinnier cape profile than what we see out in here. We do see stronger low-level shear out here. The photographs displaying much more low-level curvature there, upwards of 230 meters squared per second squared effective storm relative helicity, which was definitely more than what we saw back out to the southwest. As we went into the afternoon, though, the instability profile didn't change all that much. Here we are at 19Z. You can see, again, we maintain that skinny cape profile, and our low-level instability is definitely on the weaker side. Sub 50, 0 to 3 kilometer cape. Usually 50 is that threshold we like to see for a better chance for tornadic supercells to take place. And we're seeing sub 50 joules per kilogram here in that 3 cape value. Low-level lapse rates also on the weaker side. Still unstable, but only about 6.3 degrees Celsius per kilometer. Compare that to our low levels at Port Arthur at that time. Very much steeper low-level lapse rates there, leading to much more robust low-level instability, much more robust low-level updrafts. And so that is a stark contrast to what we saw back out to the east. And that is a big reason why I think the threat in Louisiana and Mississippi did not quite pan out as expected for the most part, is this somewhat skinny cape and limited low-level thermodynamic profile. Despite that, we still had enough instability to support tornadic supercells out there, especially with strong low-level shear. Here we are at 23Z. We do see an increase in the instability here by this point and very strong low-level shear. The problem was by this point, the QLCS was the main convective mode, and so discrete supercells were definitely waning by this time, and the QLCS was the main convective medium for these severe hazards, and therefore we were transitioning to mostly a damaging wind and embedded tornado risk rather than a long-track significant discrete supercell tornado risk. And on the storm scale, there were also some factors, particularly for the long track supercell that trekked along the Texas coast. Again, there were supercells in the northern portions of the Houston metro area that produced tornadoes, some significant. But for this supercell in particular, our long tracker, what was the kicker was this extensive line of updrafts feeding into the southwestern flank of the storm along the confluence band. This is a textbook example of Cameron Nixon's nudger theory in action. In significant tornado environments, a lot of times a supercell cannot just produce a tornado if it's a significant tornado if it's just all by itself. It needs some sort of help to balance out the storm relative inflow and the storm relative outflow. You have a lot of storm relative inflow going into the storm, especially in an environment like this with very moist low levels. You're not going to produce a lot of outflow. So if this storm was all by itself, it would probably struggle to produce significant tornadoes, especially with the background environment being only adequate for tornadic activity. Again, strong instability, strong low-level instability. Low-level shear, though, was just on the margins for tornadic activity. So we needed a little bit of assistance, and that assistance came from all of these updrafts along the confluence band, feeding into the southwest flank of the storm and nudging the supercell all the way through its path into southwest Louisiana. Throughout the entire time it was producing tornadoes, it had all of this activity along its southwest flank, and that helps to balance things out. You have strong storm relative inflow into the storm, not necessarily strong perhaps, but perhaps strengthening with time, as we saw on our soundings just a bit ago. So you needed some medium to provide storm relative outflow to balance that out. Enter all of these updrafts constantly nudging this storm throughout the entire path along the Texas coast. And we'll zoom in here to our other radar, and you can see the nudgers just continually feeding in to that southwestern flank of the storm. You can see where your supercell is, tornadoes are ongoing, and just continued nudging of the main supercell by these updrafts feeding into the southwest flank of the storm. So this was a textbook example of nudger theory in action, with all of these feeder cells feeding up into the supercell, helping to sustain that tornado for all of its time as it tracked along the Texas coast. Very interesting stuff, and this is one of the better examples I've seen of this theory in action. And just some interesting storm scale behaviors with this storm. After the storm crossed Trinity Bay, you'll see what happens here. The vortex, very strong vortex crossing onshore here just to the south of Double Bayou. Watch what happens with the circulation. It almost does a little bit of a loop, and it gets cut off from the inflow, and then we see the significant couplet return in its entirety. This could be a sign of a failed occlusion. Watch how the couplet gets completely cut off from the inflow. The greens are going toward the radar, which is the Houston radar, so it's going to be back to the west of this supercell. So the greens are going toward the radar, red's going away. So this green area is your inflow into the mesocyclone. You see it gets completely cut off from the inflow here, which means the RFD may have surged out far enough, the rear flank downdraft, to wrap cold air around the tornado and start to occlude it. But you'll notice that it loops back around almost and then quickly resumes its significant tornado production. So I'm unsure. I don't think the tornado actually ceased within this time. I think this might be an example of a failed occlusion, where this happened in the El Reno 2013 tornado toward the end along I-40. It did a little bit of a loop during a failed occlusion process, where the occlusion process starts, the RFD wraps around the tornado, cuts it off from the inflow, but not enough to cease tornado production. The tornado loops back around, connects back with the inflow, and you see significant tornadic activity resume. So very interesting little signature there that I noticed in this up-close radar imagery. But overall, just a very, very impressive look with this storm. You can see clearly the rear flank downdraft boundary right in here, this kind of shear line right in there leading right up into the tornado. Very nice high-resolution radar imagery that we can see the rear flank downdraft boundary all the way through its track along the Texas coast. You see that shear line continue. RFD will switch over to the Lake Charles radar. You can see it even more clearly here. Tornado right there, just to the southeast of Port Arthur. Shear line right there. That is our rear flank downdraft. Very clear rear flank downdraft boundary. And then finally, toward the end of the life cycle, the occlusion process occurs. The rear flank downdraft juts out ahead of the storm and undercuts the mesocyclone, cuts it off from the inflow, wraps around it, and we finally saw the tornado's life end as it crossed into southwest Louisiana. So very, very interesting storm scale behaviors with this particular supercell. Very intense tornado, a little bit of failed occlusion process there, it looks like, before the significant tornado continued off to the south of Port Arthur. All right, let's shift gears to the moderate risk, particularly across Louisiana and Mississippi. We've already started to go through some of the reasons why I think that area tended to struggle a little bit as far as sustaining robust tornadic supercells. The first reason, again, being the thermodynamics. We had just limited instability, very skinny K profiles, and very limited low-level instability, limited low-level lapse rates, and limited low-level instability. I think that was one of the main reasons, compared to farther west, why storms tended to struggle out here, despite very strong low-level and deep layer shear. Now, where did this lack of thermodynamics come from? We did start to see some clearing through the day. We started the day, as you see on visible satellite here, with quite a bit of cloud cover across much of the southeast. You see a lot of those early thunderstorms there with some of those more bubbly tops. Lots of low cloud cover, though, you see across the Gulf Coast, closer to the Gulf Coast there, southern Louisiana into southeast Texas, up into Mississippi as well. We did start to see some clearing, though, as the morning progressed. Those morning storms moved off, and we started to see quite a few breaks in the clouds, and the satellite started to get that look, if you will, that we see in a lot of these big-time southeast setups, with a lot of clearing, a lot of these little confluence bands, these convective rolls possibly in the open warm sector with some clearing. That is usually a typical satellite image of a big-time southeast event that is set to take place. But it just didn't quite happen. We see quite a bit of clearing there, but then we see all those storms move in from the west. A couple of tornadic supercells in here, particularly the Bude, Mississippi one. And then that was kind of it. That QLCS kind of took over. So it was a little bit of a weird sort of anticlimax, if you will, given this kind of satellite look. Didn't really amount to a whole lot as far as widespread significant tornadic activity. Again, not taking anything away from the storms that did occur. They were very significant. But overall, we just didn't see that widespread significant long track tornadic activity like what was forecast with this event. So what was the culprit for the lack of thermodynamics across the region? I think it did have to do with that morning round of storms. It wasn't all that stubborn. It was quite pervasive, as we talked about. As you see here, just after 15Z, quite a bit of convection across Louisiana and Mississippi. And it did move off to the northeast relatively quickly, so it didn't look like too much of an issue. But almost immediately behind it, we started to see development in the open warm sector. And I just don't think we had enough time between that morning round and the time those storms fired and moved into that air mass to fully destabilize out ahead of those storms. So most of those storms either fired back in here to the west, closer to the QLCS, and that is another reason I think that we may have seen a little bit of a lack of tornadic supercells in Louisiana, even though surface temperatures were a little bit warmer away from this morning batch of convection in Mississippi. That QLCS was pretty rapidly moving off to the east, and so we just did not have as much real estate for those storms to really get their act together in Louisiana. Out here in Mississippi, we were far ahead of that QLCS, but again, all these storms were moving right into this area where the morning storms had impacted, and we just didn't quite have the thermodynamics to really pose a significant tornado risk from multiple storms. We can see this in the surface map as well. Starting at 12Z, again, we had that broad warm sector extending over towards southern Alabama, southern Mississippi. Temperatures in the low 60s, dew points, or temperatures in the upper 60s, dew points in the upper 60s as well across Mississippi. But that didn't really change much throughout the day. As we go forward on this surface map loop, you see those temperatures don't really change at all. You see the impacts of the early convection. Temperatures drop into the mid-60s there across southwest Mississippi, and they don't really recover. By the time those supercells were moving into that area, we saw those temperatures kind of just hanging out around 68 degrees or so in this corridor, with 70s off to the west. So we didn't really see that eastward push of the warm sector and really robust low-level destabilization like we thought we might see in this corridor that really kept the overall significant long-track tornado risk down and did not allow those supercells to really sustain themselves in that environment. We did have that one supercell, though, the Bude supercell, tracking here up just to the west of I-55, southwest of Jackson. We do see perhaps a little bit of a gradient here, a little bit of a boundary with low 70s temperatures there. Vicksburg at 71, Right there, Natchez at 71 as well, with 68 here across the Jackson area and just south. So perhaps a little bit of a gradient here, a little bit of a temperature and moisture gradient right along that corridor, right where that supercell tracks. So that may have helped things with that particular supercell on its own, but for the rest of the storms, they were either in this kind of away from this boundary, or they were just to the east of the boundary and outran that instability pretty quickly. We can see the extent of the warm sector on our mixed layer CAPE plot from the SPC mesoanalysis page. The red contours are our mixed layer CAPE, and the blue shading is convective inhibition. And as we go through the day, you really don't see these red contours move all that far off to the east. We maintain a somewhat capped, somewhat less destabilized environment off to the east in the eastern half of Mississippi, and that warm sector really never pushes east like it was expected to. That instability gradient kind of right in here in southwest Mississippi, and lo and behold, that's exactly where the Bude supercell tracked, and anything to the east of that really never produced long track significant tornadoes. We may have had another tornado from the storm to the south of the Bude supercell. Here is the Bude supercell right there, moving just to the west of I-55, producing its significant tornado there, very intense rotation associated with it. The storm to the south was expected to do the same thing. As you see there, closing in on Brookhaven, strong rotation as well. May have produced a brief tornado right in there, took on a very favorable shape, likely a tornado that occurred there. But it was not a long tracker. Quickly moved off to the northeast, lost its rotation as it moved into the slightly less stable air mass. Just kind of crossed that instability gradient into the less destabilized, slightly more capped environment. And overall, and after that, the QLCS kind of took things over, and that was our main threat moving forward. So the instability axis did not really move off to the east like it was expected to, and the warm sector overall just didn't really budge from this area. We didn't really destabilize much of Mississippi to persist that long track tornado threat farther deeper into the Mississippi portion of the risk. As we've already talked about in this video, another factor was perhaps the lack of forcing in the open warm sector. Once again, we were just kind of in no man's land in the open warm sector. As we go toward 19Z early afternoon, all the forcing from the trough still back here across East Texas, hence all the convection out there in that region. Over the open warm sector, we were just a little bit too far removed from the main forcing with that trough to sustain robust, discrete tornadic supercells for long periods of time in the warm sector. In these warm sector cases, warm advection can be enough on its own to initiate these storms, and these confluence bands as well can provide enough subtle forcing to initiate these storms, but you need something to provide a little extra oomph, a little extra juice in the mid and upper levels to help those storms grow and sustain and mature and persist for quite a while in the open warm sector. And we just didn't quite have that. The trough evolution and progression with this system was just not quite optimal to really sustain widespread open warm sector tornadic supercell development for a long period of time. And with the QLCS coming in from the west, that chance to do so was becoming shorter and shorter with time with these supercells as the warm sector was getting pinched off from the west as that QLCS came through. So supercells that did try to persist, especially those across Louisiana, just didn't have enough time to sustain themselves and mature into tornadic supercells there. The ones across Mississippi did try to do that, but again, the farther east you went, the less the forcing was behind the lead shortwave and ahead of the main shortwave, a little bit too far removed from the main forcing with this main shortwave. Compare that to an event that had a lot of warm sector convection, April 27th, 2011, the super outbreak across the southeast. Our warm sector was situated across Mississippi and Alabama. Here is our 500 millibar trough progression on that day. Our jet streak started the day at 12Z out across the southern plains, and watch what happens here as we go forward with time. That jet streak really takes on a negative tilt with time, and that jet streak, the stronger flow aloft with that jet streak well over right over the warm sector, trough axis somewhere right in here. So we were right ahead of the shortwave axis under the influence of the stronger flow aloft at 500 millibars. So we had plenty of forcing to allow storms to fire up in the warm sector on that warm advection regime, but also to have them sustain with stronger forcing aloft to allow them to persist. You can also have something in the lower levels, about 700 millibars, as far as such as a shortwave move through the warm sector that can help provide a little bit more subtle forcing to sustain supercells as well. Here's your 700 millibar map on April 27th, 2011. And lo and behold, a little bit of a shortwave developed out in the open warm sector. You see a nice little ripple in the flow right in there developing by early afternoon that helped to give a little bit of extra forcing for those warm sector storms to persist. And we just did not have that with our December 28th case. Here's our 700 millibar map on that day. And we just don't see much in the open warm sector behind that initial shortwave. Again, there was some subsidence on the backside of that shortwave, and our main shortwave still back in here. So we're just kind of caught in the middle in this area. Not enough forcing to really help those storms persist. And that's why a lot of the mesoscale discussions on that day, on Saturday, talked about how storm intensity might fluctuate. We might not have enough to allow long track tornadic supercells to develop and persist in the warm sector just because of the lack of forcing. It was lagging a little bit too far back off to the west associated with the main trough. So that's going to do it for this video. Hopefully it gave you a little bit of insight into some of the reasons why the southeast Texas portion of the risk may have been a little bit more robust than expected, and why some of the moderate risk did not quite live up to expectations as far as the significant long track tornado threat goes. Still, we had a bit of tornadic activity, significant tornadic activity at that, especially this tornado near Bude and McCall Creek. Very visible, photogenic tornado there that did some significant damage in western and southwestern Mississippi. And that storm in southeast Texas was certainly a beast. Some very interesting behaviors with that storm as well. There will be more tornado reports that are probably added to this in the coming days, especially from the QLCS portion of the event. But overall, definitely an event that was far from a bust, with over 50 tornado reports, 340 severe weather reports in total as of the recording of this video. Lots of wind reports, a few hail reports, and over 50 tornado reports. Certainly a severe weather outbreak to close out 2024 in dramatic fashion. So that's going to do it. Thanks for watching, and we'll see you in the next video.